Hello students. Today I am going to explain to you how to find angle between two planes which are in vector form in 4 easy steps. Okay. This is the major formula, the formula to find the angle between the two planes. Angle between two planes is the angle between their normals n1 and n2. So this is the diagram. This is plane pi 1 whose normal vector is n1, and this is plane pi 2, the green one, whose normal vector is the green one, n2. The angle between them will be theta. Okay. Okay then. So let us see how we are going to find this. Right. Yeah. So this is the question. If you remember, we will continue the same question which was from the past paper. The plane pi 1 has the equation 3x minus y plus 4 plus z, is equal to minus 11, and the line L has the vector equation r is equal to 1 2 minus 2 plus lambda times minus 3 minus 1 4, where lambda is a real number. So in this plane we have the line r. Okay. Sorry, this is the plane and this is the line in vector form. Now plane pi 2 contains the point O and line L. See, second plane pi 2 contains this line, right? Plane 1 doesn't have this line. Plane 2 has this line, right? Okay. Now the plane pi 2 contains the point O also and the line L. These two things are there, right? So we have to find D part of this question. Determine the acute angle between the planes pi 1 and pi 2. This is 5 marks question in AAHL. Okay. So look at the steps. Step 1, extract the normal vectors. Normal vectors to what? Normal vector to plane 1 and normal vector plane pi 1 and normal vector to plane pi 2, right? Now equation of plane pi 1 is this. So I wrote it here. Its normal vector is given by 3 minus 1 1. I hope you know it. N1 is equal to the coefficient of x 3, the coefficient of y minus 1, and the coefficient of z 1, right? So this is the normal vector n1 to plane pi 1, right? Now plane pi 2 contains vector OA. It is given already in the question that point O is in the plane, line L is in the plane, and on the line L we have a fixed point 1 2 minus 2. Okay. See, this is the equation of the line. On this line 1 2 and minus 2 is a fixed point, and minus 3 minus 1 4 is the direction vector of the line. I hope you know about it. So line L has this point A 1 comma 2 comma minus 2, right? So using O, the coordinates of O 0 0 0 and the coordinates of A, we find the vector OA, right? Position vector of the point A. Then the direction vector of this line L is this minus 3 minus 1 4. Okay, so I wrote it here D. D is the direction vector. Hence the normal to the plane pi 2. Normal to the plane pi 2 will be perpendicular to the plane, and a vector perpendicular to the plane will be perpendicular to these two vectors, because these two vectors are in the plane pi 2. They are contained in the plane pi 2. So therefore we find the cross product of OA and D. So N2 is OA cross D. Okay. So N2 is the vector OA and the vector D. Now their cross product is given by this formula. Okay. So how do we write? Where V1, V2, V3 is the first vector, W1, W2, W3 is the second vector. So how do we write that cross product? V2, W3. See, this is V2, this is W3. So 2 into 4. Then V3 W2 minus. So this is V3, this is W2. Minus 2 into minus 1, which is here. Then second component is V3 W1 minus V1 W3. V3 W1, V3 W1 minus 2 minus 3 minus V1 W3, V1 W3. So V1 W3, 1 into 4, right? Then the third component of this cross product, V1 W2, V1 W2, 1 into minus 1, okay, minus V2 W1, V2 W1, 2 into minus 3, okay. So after simplifying these three components, I get 6 to 5. I hope you understood this. So now we have two normal vectors to both the planes. Phi1 has normal vector n1, 3 minus 1 and 1. Phi2 has normal vectors n2, 6, 2 and 5. I hope you understood this. Now we have the second step. Okay, we found the normal vectors. Now calculate the dot product of those normal vectors. So n1 is this, n2 is this. Their dot product is given by this one, which is by this formula in your formula booklet. Okay, v dot w, v1 w1, v2 w2, v3 w3. This is vector v, this is vector w. So their dot product means the respective components we multiply and add. 3 times 2, 6, minus 1 times 2, minus 2, plus 1 times 5 here. Simplifying that, I get 21. 21 is the dot product of n1 dot n2, right? Next step now, step 3. Find the magnitude of normals. Magnitude of normals. First vector, normal vector n1 is 3 minus 1, 1. So its magnitude means the square root of each component is square. So 3 square minus 1 square and 1 square, which is square root of 11. Then the magnitude of vector n2, the normal vector n2, will be 6 square, then 2 square, then 5 square, which is square root of 65. Okay, now the last step, fourth step, will be solve for the angle. Now the formula for the angle is cos theta is equal to V1 W1, V2 W2 plus V3 W3, which is the dot product of two normal vectors. Okay, divided by their magnitudes. So I wrote it here correspondingly. N1 dot N2 divided by magnitude of N1 into magnitude of N2. N1 dot N2 we already have here. See, I'll show you. N1 dot N2, N1 dot N2 is 21. Okay, so I am putting it there. Okay, N1 dot N2 21 and the magnitude of N1 and magnitude of N2. Okay, then cos we take it to the other side, it becomes cos inverse. So theta is equal to cos inverse of this right hand side, which by calculator will be like this, which is in the radian form. So with this, I end this lesson. See how simple it was. I hope you understood this. If you need any other problems to be solved by me, please contact me or message me on my WhatsApp 9326363793. Okay. And now we have completed the whole question. Therefore, the PDF of all these three lessons you will find the link of it in the description of this video. Okay. Okay then. Bye. I hope you understood everything. With this, I end my lesson, right? Okay then.